Hello class, this is Tim Tomlanovich. This is Construction Methods and Engineering Inspection. This is your lecture for Learning Plan 1. Okay, Learning Plan 1, the construction team. Okay, so let me get the slideshow going here. There we go. So who's involved in a construction project? Civil engineering construction project, roadway, commercial building, anything. So first you have the owner. The owner wants to build something, and then owner will probably hire the architect to design it, and the architect will need the engineer, the civil engineer, the mechanical engineer, several engineering disciplines to engineer the building, and then we have the construction contractor, excuse me, construction contractor to build it, or sometimes the construction manager will manage all these. We have the subcontractor working underneath the contractor, and then we have the inspection testing. So you kind of fit in this role. So these are all the team players. So you got the owner, architect, engineer, contractor, construction manager, and subcontractor. So a traditional relationship, typically the owner wants to build a project, he'll hire the architect, okay, and then the architect and engineers work together. So this is typically what I did in my years of engineering is I'd be working for the architect because we'd have to work closely together to figure out how that building was going to be designed and constructed. Okay, and then typically the architect, and then there's the contractor, and the inspection and testing would all fall underneath the architect, and then sometimes typically the contract would be through the architect, but sometimes we may go directly through the owner. Okay, so a lot of times the architect handles this, and then some subcontractors obviously fall underneath the contractor. So that's kind of like a traditional relationship. The owner has a project, architect designs it, engineers design it, it goes out to bid, contractor builds it along with its subcontractors, and there's inspection and testing due to the specifications. Construction manager relationship. So sometimes to really reduce the amount the owner has to be involved, the owner will hire the construction manager to oversee everything. So these dashed lines are like, yeah, they're connected, but they're not on the day-to-day operations like the previous one. So the owner will hire the construction manager will hire the architect. The architect hires their engineers. Sometimes, most of the time, they're in-house, but me as a geotech, I would be in this category. So it would be design the building, and then the construction manager would manage the architect along with the contractor, inspection and testing, and subcontractors. A little less onus on the owner. So basically the owner, the construction manager and the architect reports back to the owner. Design build relationship. Completely, owner doesn't want anything to do with it. Owner completely hands off, as you can see. The owner will hire the contractor, and then the contractor needs to hire the architect, engineer, subcontractor, and inspection and testing. Okay, so this is typically the contractor's building it at the same time as the engineers and architect are designing it, and they're working very closely together to get this thing built. Typically in a traditional, in the previous relationships, typically the contractor's not even involved until after the design is done and the architect it's done. So in this relationship, the design build, hence design build, the design is being built at the same time, so there can be changes back and forth. Okay, and there's liability in between the two, where before the design would be completely done, it would be put on the shelf, and then it goes out to bid, and then the relationships happen. So what is an inspector? The eyes and ears of the engineer and owner, vital teams of the team. There would be no direct involvement in the construction of the project by the engineer or owner without an inspector. So once us engineers are done, we're not sitting out there watching what's going on. That's what the inspector is doing. Federal construction contracts typically require an inspector under Principle of Contractor Quality Control, CQC, Principles of Contractor Quality Control. Categories of inspection: construction inspection, code enforcement inspectors, special duty inspectors, testing laboratory inspectors, governing agency inspectors, and fabricator or manufacturer inspectors. So construction, so you're inspecting the construction. Code enforcement, they're just making sure the codes are being followed. Special duty, that's hence the term special. I'm sorry, deputy, special deputy. So that's a very specialized. It could be in a government agency, federal government level. Lab inspectors, government agency, DOT, and then a product that's being produced on a assembly line. Those are the fabricator manufacturer inspectors. Okay, construction versus code enforcement inspection. So I just wanted to determine the difference. You can do both, but this is the difference. Code enforcement inspection: compliance with safety and health provisions of the applicable building code and the terms of the building permit. Not concerned with quality of work or contract compliance. Basically, they show up at certain parts of the construction, they look at it, they leave, they sign off on the building permit. Okay, so I did a fence last summer. I hired a fence contractor. I got the building permit. I gave him my design. The building permit was issued. The contractor built my fence. I didn't see the building inspector. I was kind of out there watching them. The building official came back. Was the fence built according to the permit? Check. Did any codes violated? Nope. So it's done. So really simple. Construction inspection: responsible for full compliance of the contract, responsible for quality and workmanship. So you're more involved. You're there from beginning to end. Where do you fit in? Construction inspection. The inspector's qualifications, duties, responsibilities are typically defined in the contract documents. And this will be learning plan 2, where you define your contract or your duties are in the contract documents. Concept of inspection and testing: aids the selection of materials and prediction of their serviceability. Quality construction requires inspection and control. Aids in the preparation of adequate specifications. Provides protection of mutual interest. So you're a very integral part of the team. So due to your training, understanding, have a good background of design, you need to be out there watching that it's being constructed how we design. So, you have lots of moving parts out in that workforce on a construction site. A lot of times they're just told to go move that soil pile from point A to point B, but not knowing why they're doing it. So that's where you come into play. Definition of testing: the physical performance of operations to determine quantitative measures of certain properties. Testing determines quality in the lab. This is key. Testing discovers facts regardless of results. That's it. You're not there to judge it. You're just there to report results. The observation and examination of processes and products of the construction to assure satisfactory work in accordance with plans, specifications, and terms and conditions of the contract. Okay, there's a lot to know. So when you're going on site, they're going to hand you a spec book and a plan set. Before you even want to go outside, you better review that specification book, understand your roles and responsibility, and get yourself familiar with that spec book and plans, because you want to make sure it's being constructed to that. Okay, inspection may involve testing, aims at control of quality through application of established criteria and processes, involves rejection of substandard material or processes, involves human relationships as well as technical duties. So you gotta work as a team out there. Specifications attempt to tell the contractor what is wanted. Statements of standards of quality, not necessary for the ideal material, but for material possible to obtain at a reasonable cost to meet minimum requirements. So this is a great example now in our COVID days now. is, we may specify a certain product to for the specification to be, but maybe due to COVID, we cannot that product cannot be produced. There's delay in construction or manufacturing of that product. So sometimes what we'll have to do is find an equivalent product of that will meet the design needs. It could be higher cost or it could be a lower cost that helps save money. So that's sometimes happens, and that's where you're involved, because you're in the day-to-day operations out there with the inspection. Definitions of types of specifications. We have performance related, performance based, prescriptive, proprietary, end result, quality assurance, and standard. So your class discussion learning plan 1 has you go through and determine what are these specifications. Okay, define them and give examples of each. So I'm not going to go through those. So I'll leave that up to you. All right, standard specifications. Agencies include associations, technical professional societies, municipal, state, and federal agencies. Standard specifications, standard. So not contract specifications, project specifications. This is a standard specification. So they include standard methods of testing, standard definitions, material quality, and property. So as you look, ASTM, AASHTO, ACI, Asphalt Institute, USAC, WISDOT, MDOT, and others. So these develop those standard specifications of how I need to test it and the material properties. So ASTM is big in materials testing. Me as a geotechnical engineer. So roadways, the WISDOT or MDOT, whatever state, they have their own set of specifications that they want to follow, and they have material properties and qualities, and they actually fall under AASHTO, America's Association of State Highway and Transportation Officials. So the inspector is to inspect the workmanship, materials, and manner of construction of all of the structures and appurtenant work or portions of such structures in order to determine whether the requirements described by the plans, drawings, specifications, contract documents, codes, ordinances, or other statutory provisions are met by the observed work. That is a big responsibility when you're out there. So you need to be familiar with all of that. So it's a very important job. So who can you represent? Owners, design firms, engineers, architects, public agencies, states, cities, villages, towns, contractors, because they have to do construction quality control, subcontractors, manufacturers, or suppliers. What is your responsibility of the inspector? Be familiar with plans and specifications. Notify contractor promptly if work or products are non-compliance. Perform duties that will progress work, inspect and test work properly as it progresses. So you got to plan ahead. Plan ahead. Make sure you're ahead of them so you don't slow them down. Avoid performing work not in the scope of work, so don't make them do something that's not in the contract because it'll issue you a change order. Inspect operation the entire time work is proceeding. Now, there are sometimes they don't want us there full time because of the cost. So, and then something goes wrong, and then they try to blame it on the inspector. But in our contract, it'll say, daily reports, and we'll go over daily reports. Well, we were only there part time, so there are gaps when we weren't observing the construction, so we can't be liable for that. So, and when you're there, look at things, watch things, even though it's not in your scope of work. Just watch things and learn how they're constructing things, and say this doesn't look right, or does this seem right, even though you're not supposed to say it. And just don't go sit in your truck until you're ready to test and stare at your phone. Observe what's going on. Make relationships. Daily report, prepared recordings, days happenings, perform on-site tests expeditiously. Okay? Don't hold them up. Be ready. Report any non-compliance to engineer or owner. Anticipate problems in advance. Try to say, oh, that's not going to pass, so maybe you can help them, but just be careful of that. Perform on-site testing expeditiously. Okay. Typically, they'll call you at the last minute, then you're all breathing down your neck, but you need to do your job in a quality way. Seek assistance of engineer if required, gather all facts, seek necessary advice, and thoroughly investigate situation to avoid making hasty decisions. Don't panic, everybody. Just gather your advice, take your time, get the facts, do the testing in accordance to ACI, etc. Make sure you're doing it correctly, make sure your equipment's calibrated, and then, then you start, okay, hey, we may have a problem. And then if something fails, like a density test or a slump test, re-inspect the corrected work and follow up with proper documentation, including a daily report to make sure, yeah, this failed, but the contractor did this at this time, they fixed it, I retested it, and the test passed. So that's very important. Stand by your word, be careful of words and actions. Differentiate between essential and non-essential items. What's critical at that time? Okay, don't be testing, I guess, the foundations way on the backside of the site when they're not even close to placing concrete versus where they're ready to place footings and you haven't tested the foundation yet and the concrete truck's sitting there. So itemize your ideas. Report any safety issues to contractor and engineer. Report situation that may delay work to the engineer or owner. So safety issues. So safety is number one. Okay, be careful. Just be safe. Inspector authority. Approve materials and workmanship that meet the contract requirements in a timely manner. Should not stop work. Should not approve deviation from contract requirements. Should not require contractor to furnish more than required. Don't stop work because then that's a delay of work. That's going to go back on the engineer. Don't approve any deviations unless you heard that unless it came through the pipeline, through the superintendent, through the engineers, and you see documentation that this is okay. So you got to make sure you have the documentation. And don't have the contractor do more than what's required. Should not direct contractors' work. Don't tell them how to do it because you may think you have a better way of doing it than he's doing it. You just took responsibility of his work. Should not provide suggestions. No, that's kind of a gray area. So, this is that relationship building. A lot of times if you build a good relationship and you're planning ahead and you're looking at things, you kind of, this is where that a good contractor will like us out there because we're helping them get the project done faster. That means more profit in their pocket. And if you build that relationship, they'll work well with you, they'll help you out, so that's that relationship. So you don't want to be that inspector that holds up a stop sign and they say, oh, they all scatter when you go run out because you're going to see something wrong. So that's why it's important that you be there. You're not in your truck just staring at your phone. Go out there and talk to them, and make friends with them. You don't have to make friends, but just, have a respect to them because they know what they're doing and, explain to them, hey, I need to test this at this time, and if they know that ahead of time, they'll be more reluctant to help you versus resist you if you explain your role out there. And that's usually defined in a pre-construction meeting. Only speak to the contractor superintendent or foreman, not any workers or subcontractors. Especially if something's wrong, if test fails, make sure you follow the chain of command. Typically, they don't like you talking to the workers because then as soon as you direct the work, the superintendent gets mad at you and then you have to reshift they get mad. So just be careful who you talk to. Follow the chain of command. All right. Essential requirements of the inspector: professionally and ethically represent the owner, engineer, architect, and organization. That's depending on who you work with. Who's paying your bill? Okay, who is paying your bill? That's the key. Follow the contract. Look at the contract documents. Judge the quality of the product or process in relation to some form of written specification. Interpret specification in terms of both limitations and intent. So this can get gray. So this is where you need the contractor will ask questions. You ask questions of the engineer and make sure, because we want to, what is the intent of that specification? You need to know that. So if you don't know, ask questions. Strive for the highest quality consistent with terms of the contract documents and specifications without causing delay or completion without proper cause. Do not direct, supervise, or suggest means and methods. Key: be firm but fair and be assistance to the contractor. And that is it with this presentation for Learning Plan 1 of Construction Methods.